Hello everyone. Now we are going to solve LeetCode problem number 219. Contains duplicate. We will solve this problem by sliding window. This can be also solved with like simple iteration and all, but if we solve it by sliding window, the time complexity will be very less. So in this problem, what we have to do, we have to check if any number present in the array that appears like twice, the number that appears twice, which index gap like it is either k or less than k. So here we are given a example. So we first initialize two pointers I and j starting from 0 index. We also be using set in this to store the elements. So also we have declared set, so it is our set, right? So here we have a while loop. While j is less than n means j will go from here to here. N is the size of the array given, so j will move from here to here. And what abs means? Abs function means absolute value. Like if here we have minus x, then it will return to minus of minus x means basically it always gives a positive value. Whether inside this we have negative value or positive value, it will always give a positive value. So now let's start. One more thing, insert means we are inserting that value into the set, and same erase means set is st. And erase means deleting the value from that set, like it is written like this. Here something will be written and that value of something will be deleted from the set. So now let's start iterating. So first we have I starting from 0 index. Here these are indexes of the element. Like first element we have at 0 index, then 1 index, then 2 index, all. So let's start iterating. First we are checking absolute of I minus j, 0 minus 0, which is 0 minus 0 is 0, so absolute of 0 is 0. Is it greater than k? 2. No, not. So this condition is not true. Again we check st dot find. Find means st dot find is if st dot find is written somewhere, it means we have to check this element is present in the set or not. And st dot end means that the element is not present in the set, right? So st dot find nums of j. Nums of j is nums of j. What is the value of j now? It is 0. Nums of 0. So nums of 0 is 1. So st dot find 1. Is 1 is present in the set? No, set is empty now. It is our set st. So it is not present. Also this loop is also false. It won't be executed further. So we insert nums of j. Nums of j was 1. Nums of j value is 0. So nums of j was 1. So we insert 1 into the stacks. Oh, sorry, I said stack. It was set. So we insert 1 in the set. After that, we move j one step forward. So j is here now. 0 plus 1 is 1. Again, we move till here. Again, we start from here. So absolute value of I minus j 0 minus 1, it is 1 minus 1, absolute changes is into a positive value. So 1 is greater than 2, no it's not, so this won't be executed again. After that we again find st.find nums of 1. Nums of 1 is 2, so is 2 is present in the stacks? No, we have only 1. Again this is false. So what we do, we insert value of nums of j. Nums of j was 2, so we again insert 2. We move j forward. J plus plus means we are moving j in forward direction 1 times. J is again absolute of 0 minus 0 is the index of I and 2 is the index of j. So 2 is greater than k. No, 2 is equal to 2, not 2 is not greater to 2. Not greater than 2. So this won't be executed again. Again we check st.find nums of j. We are at 2, j is equal to 2, j is equal to 2, we have 3, nums of j is 3, so is 3 is present in the stacks. Now I'll move faster. So nums of j was 3, so insert nums of j, it is 3. After that we move j 1 point forward. So again we check absolute of 0 minus 3, it is 3, it is greater than k, yes. Now it is greater than k, this condition is true now. So what we do, we erase the nums of I. Nums of I was nums of 0. Nums of 0 was 1, so we erase 1. So now 1 is deleted. After that we move I pointer 1 step forward, so I is now here. This loop is executed. Now we move to this loop. If st.find or find nums of j. Nums of j was 1. Is 1 present in the stacks? No, because 1 is deleted now, so we don't have 1 in the stacks again. So what we do? Again we move to another things which are written further, because this is not executed. So what we do, insert the value of nums j. Nums j value was 1, so we insert 1 here. Again j plus plus, j move here. We again check absolute value of I minus j. I was 1, now I is 1, because I is here, here. So it is not 2, because 2 is the element. We have to check the index. I is index, so the index of I is 1. So 1 minus 4, which is 3. So 3 is greater than 2, here it is. So what we do, we erase the nums of I. Nums of I was 2 from the set. Nums of I was 2, so we erase 2 and move I 1 step forward. So I is at 3 now. Again another if condition, st.find nums of j. Nums of j was 2. This 2 is present in the stack? No, because that 2 what was present is deleted. So we have only 1 and 3 in the stacks now, so this won't be executed again. So again st.insert will insert the value of nums of j. Nums of j was 2, so we insert 2 and move j 1 step forward. So now j is moved till here. Again same condition, absolute of I was at 2. 2 minus 5 is 3. It is greater than k. Yes. So what we do? We again erase nums of I. Nums of I was 3. So we again erase 3. Again after that we move I pointer one step forward. Now this condition st dot find nums of j. Nums of j was 3. So is 3 is present in the stack? No, it's not, because we have only 1 and 2 in the stack. Oh, why I am saying stack? Set. So it is not present. So yeah, 3 is not present. After that we insert. I have been solving stacks problems for a long time. That's why I am not able to pronounce as set. I am saying stacks and stacks again. Nums of j was 3. So we insert 3. After that we move j pointer forward. Again, absolute of 3 minus 6. It is 3. It is greater than k. Yes. So what we do? We erase nums of I. Nums of I was 1. So we erase 1. After that we move I forward. I is here. Now this condition st dot find nums of j was 2. So is 2 is present in the stacks? Yes, 2 is present. We have deleted 1, but we haven't deleted 2, because we have to delete the ith index element. So ith index element was 1. Before we move I plus plus, I was here and the element was 1. So we have deleted 1, not 2. So 2 is present in the stacks. We have find 2 is present. So what we do? Return true. After that we return true. That is our answer. True. Because it is a Boolean function. It is a Boolean function, so we have to return true, either false. So yeah, that was the problem, and we return the true. After that we exit everything, and that is our answer. We have found the duplicate elements in which the window size is either k or less than k, right? Window size is either less than k. So that's all for today. Thank you so much for watching.